Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is find median from the data stream. So it's a hard level question and it's a very popular question, as you can see from the likes. So let's read the problem statement. The median is the middle value in an ordered integer list. So we are given with an if we are given with an ordered integer list, then the median is the middle value actually. So if the size of the list is even, then there is no middle value and the median is the mean of the two middle values. So if you see this example, the first array given 2 3 4, the median is 3, right? It's because the 3 is lying at the middle of the ordered stream. Now if you see the second array 2 comma 3, the median is 2 plus 3 divided by 2, because there is no middle value, so we have to take the mean. Now we have to implement a median finder class, which has a constructor median finder, which initializes the median finder object. And there are two methods. First is add num, that takes an input as num and adds the integer num from the data stream into the data structure. And find median, which returns the median of the elements added so far, right? So let's see an example of the data structure that we have to write, that is called median finder. So first we call a median finder constructor, right, that will initialize the median finder data structure or the median finder class. Now we call add num, that calls the add num method with the input 1. So we have, it will add the 1 into the data structure. Now again we are calling add num with the value 2. It will again add this number into the data structure. Now we will call median find median, that will find the median of the elements added so far. So if you see 1 and 2, so the median of 1 and 2 is 1 plus 2 divided by 2, that is 1.5. Now again we will call add num, that will add 3 into the data structure. And then finally we call find median, that will find the median of the 3 elements added so far, that is 1 2 3. So 2 is the middle element of the ordered stream, so we'll return 2. So let's see how we can solve this problem. I have taken an unordered array, right? So let's see the idea and the intuition behind solving this problem. So the idea is we will be dividing this array into two parts, one with the container containing the low numbers and one with a container with high numbers. So why this low numbers and high numbers? If this is an ordered stream, right, the corresponding ordered stream for this 4 is a median and it is dividing it into the low numbers, two parts, one with the low numbers and one with the high numbers, right? The same idea can be applied in this unordered. So eventually this 1 2 3 will be added in the low numbers and 5 6 7 will be added into the high numbers. Now the median, that is 4, right, can be added, can lie in this low numbers or in the high numbers, because the size of this array is n is equal to odd. So suppose if 4 lies on the low numbers, right, if the 4 lies on the low numbers, now the size of this container is 1 greater than the size of the container containing high numbers, right? And if the 4 lies in no number, we will take the max of it, max of all the numbers in the this container. And if 4 lies in the container with high numbers, then the size of this will be greater than the this container with 1. Now if 4 lies on this container, we will take the minimum of this high numbers, right? So that is the case when n is odd, right? So how we can change these containers into a data structure which will give us this max and min in constant time, maybe order of 1. So we will use heap. We will use two heap. One, to calculate the max of low numbers, we will use max heap, and for to calculate the min of high numbers, we'll use the min heap. Right now, there can be two cases. And now for the n, this was for n equal to odd. Now n can be even as well. Right, for the even, these two containers, max heap and min heap, max heap and min heap will contain equal number of elements. Right, so suppose there is 5 1 2 3 4 6 7 8, then it will contain 1 2 3 4, and the other container will contain 5 6 7 8, equal numbers. Then we'll take the max of from this container and min from this container, and we'll calculate the mean of it. Right, now while adding into the max heap and min heap, it can be the case that one of the heap can size can become greater than the other heap size for more than one. Right, so if this is a max heap and this is min heap, so if the size of the max heap and min heap, so if max minus min is greater than 1, or vice versa, if min minus max is greater than 1, so we have to balance the heaps. Right, so if the size of max heap is greater than the mean heap by 1, so we'll transfer the max element from this max heap, and we'll transfer it to min heap. Right, and if min heap size is greater than the max heap by greater than 1, we'll take the minimum from it, and we'll transfer it to the max heap. Right, why we need balance? Because if you see, when we talked about the ordered stream, median is always the balance. It is dividing the array into balanced parts. So let's see some examples to to dry run the concept or the idea that we learned. So we'll take an example that is 5 6 1 2 3 4 7. So we'll start iterating this data stream, that is an array, one by one. We will maintain two heaps. Right, this will be min heap and this will be max heap. Right, so this will maintain the max of low numbers, and this will be min of high number. So we'll iterate over this array. So we'll see the first element, that is 5. So 5, because we'll start with the max heap, as max heap is empty, so we'll add the element into the max heap, and this will be the current max. Now we'll see the 6. So 6 is greater than 5. Right, and we have to maintain the low elements here. So we will be adding 6 in the min heap, and this will be the current min. Right, now again 1 is smaller than max. Right, and as this max heap is maintaining for low elements, so we will add 1 into it, but the max is still 5 in this max heap. Now we will see 2. So 2 is still smaller than 5, that is the maximum element in max heap, so we will add 2 into the max heap. Now the size of the max heap is 3 and size of the min heap is 1. So 3 minus 1 is equal to, which is greater than 1. So we need to balance. So to balance, we will take the maximum. We'll take the maximum from the max heap. So we will remove this element from the max heap, and we will add into the min heap. So we have added our max to min heap, and this min will change from this to this, to 5. And in this max heap, now the next max is 2. Now we will see 3. So 3 is greater than 2. Right, so it does not belong to the low numbers, it is belonging to the high number, that is in the min heap. So we will add 3 in the min heap, and now as 3 is smaller than 5, so the new min will be 3. Now we will see 4. So 4 is again greater than the max in the max heap, so we will add 4 in the min heap, but the minimum is still 3, right? Now if you see, the size of the min heap is 4 and size of the max heap is 2, so 4 minus 2 is equal to, which is greater than 1. So now again we have to balance, we have to balance. So what we will take, we will take the minimum, we will take the minimum of the min heap, because now min heap is greater, the size of the min heap is greater than max heap. So we will take the 3 and we will point and we'll give it to max heap, right? And we will remove the min here to 4. Now 4 is our current new min, right? And max is not 2, the current max is 3. Now we will add 7. So 7 is greater than max, so we will add 7 in the min heap, right? So what is the size of min heap? So as we can see, min heap size, so if we want to find median, now if we call find median method, so as we can see, the min heap size is greater than max heap size, so we will poll the element from the min heap. So min heap will give us the minimum value, that is 4. So 4 is the median, 4 will be the median, right? So if you can verify this as well, so this, if we arrange this in ordered stream, so 1 2 3 4 5 6 7, so 4 is the median evidently, right? So let's see one more example. Now suppose we have 1, right? Now suppose in the same example we have one more element, that is 1. Now eighth element, now we had done for the 7. Now if we add 1 again, if we add 1 again, so we'll see, we'll compare with the max heap, right? We'll compare with the max heap, max element, that is 3. So 1 is smaller than 3, so we will add 1, so we will add 1 into the max heap, right? Right, into the max heap, and the max will keep on pointing to 3, the maximum element of the max heap. So the min is pointing to 4 and max is pointing to 3, but so the size of min heap is 4 and size of max heap is 1 2 3 4, right? Max heap is also 4. So when the size is equal of both the heaps, then we what we do is mean of the minimum element from the min heap and maximum element from the max heap. So minimum of 4 plus 3 divided by 2, it is 7 by 2, that is 3.5. 3.5 will be the median. So let's see the code part of it. So we have implemented our median finder class as asked in the question, and we have defined our two priority queues, that is max heap and min heap. So max heap will be a heap for low numbers, and min heap will be for a heap for high numbers. And we have defined our constructor, right, where we have initialized the max heap, which will sort the numbers from high to low, right, in the decreasing order, and this min heap will be in the natural ascending order. Now the add num method, this method, which is taking the number, and first we are checking if the max heap size is equal to 0, or if the maximum value in the maximum heap is greater than num, then we are storing in the max heap only, because it's a low numbers. Else we will store in the min heap because it belongs to the higher numbers, and we will balance. So in the balance step, what we are checking, if the min heap dot size minus max heap dot size is greater than 1, so we will pull the element from the minimum heap and put it into the max heap. Otherwise, if the maximum heap size is greater than minimum heap size by more than 1, then we will pull the element from the max heap, right? We will take the maximum element from the max heap and put it as a minimum element in the min heap. And finally, the find median method. So find median method will check whether the size of the max heap is greater than min heap, then will return the maximum value from the max heap. Or if the minimum heap size is greater than the max heap size, then we'll return the minimum value from the min heap. Else we'll have to return the mean value. So we will take the maximum value from the max heap and minimum value from the min heap and divide by 2. So let's run this program. So yes, all the test cases are passing, right? So it means we can also submit the solution. So yes, all the submit is also successful. So let's see the time and space complexity. So for if we talk about the time complexity, so for time complexity for add num, it will be log n, right? It will be log n, because for adding into the priority queue it takes log n time complexity, right? And for the time complexity of find median, because we know that we have to find the maximum and the minimum heap elements, right? So for the max heap to give us the maximum element, it will be order of 1, right? And for min heap as well, it will be order of 1. So to find the median, the time complexity will be order of 1, right? Now if we talk about the space complexity, so we are maintaining two uh, two priority queues, right? Where the total number of elements will be stored actually in two halves. So in the whole it will be order of n, big O of n space complexity. So thanks for watching this video. If you like this video, please share and subscribe. It will keep me motivated to bring all these such videos in front of you. Thanks. Bye.